Welcome all of you to this video lecture series on fluid techniques. This lecture is on topic number 1 on introduction. The title of this lecture 6 is Contents and Objective of the lecture series, which is the last subsection corresponding to the first topic on introduction. I'll present the content and objective separately for the lecture series. Let us get started with the content. This corresponds to the last section of the first topic on introduction. Thereafter, there is a topic on fluid statics. This course on fluid statics, first we will study the fluid under stationary condition called as fluid statics. Then we will consider flow in motion, which corresponds to fluid dynamics. Before moving on to fluid dynamics, there is a topic on fluid kinematics where we will present the description of the motion without bothering about the forces which causes this motion. Then there is an analysis which we will do, which is called as an integral analysis. Integral analysis, both this analysis, later on in the next slide I will show you differential analysis. The integral and differential analysis are done for the mass and momentum conservation law. So in this slide I am showing you the integral analysis of mass conservation and Bernoulli equation, and thereafter we will have an integral analysis of momentum conservation. This integral analysis of a fluid mechanics problem consists of a control volume which is large enough, whereas when later on I'll show you a differential analysis which consider a very small control volume. So in an integral analysis, like if you do an integral analysis for flow across a car, this integral analysis will give you the effect of the flow across a car, which could be like a drag force acting on the surface of the car, but it will not give the flow information like point by point how the velocities and pressures are varying. So this integral analysis, which is relatively simpler from the differential analysis, gives you an overall information, the overall effect of the flow across an object or in an internal flow. After this integral analysis, next slide I will show you differential analysis. In the next topic which will be presented is dimensional analysis and modeling, which corresponds to a very important concept in fluid mechanics, which leads to the non-dimensional study. Thereafter, an internal flow in pipes will be presented. In the previous slide, I had shown you integral analysis, and in this slide, I am introducing a differential analysis. This differential analysis, for the same problem which I discussed earlier, flow across a car, will not only give you the drag force acting on the surface of the car, but it can also give you a much more detailed point-by-point information for the velocities and pressure in a flow domain. In a differential analysis, we take a much smaller control volume and we derive certain differential equations. Now, we derive this differential equation by taking the elemental control volume whose size delta x and delta y tending to 0. That's why it's a very small control volume which tends towards 0. And then we obtain a differential terms. Now, this differential equation are the governing equations in fluid mechanics. And as you know, the solution of any differential equation is a functional relationship. So with this differential analysis, when we obtain the solutions, we obtain point-by-point information. We obtain velocities, pressures, as a function of spatial and temporal coordinates. However, for a general fluid mechanics problem, this differential solution of this system of differential equation is not possible, and we have to go to computational methods. However, for some simple situation, there are certain analytical or approximate solutions which are possible. These approximate solutions will be presented in this topic for boundary using the boundary layer theory and image vector theory. Thereafter, there is a topic on external flow of body where the concept of lift force and drag force will be presented. Towards the last part of this lecture, although this course is mostly on theoretical fluid dynamics, and towards the end of the lecture, there will be an introduction to computational fluid dynamics, which can solve most of the real-world problems and is becoming extremely popular nowadays. After the content, the objective of this lecture series is presented here. The objective of this lecture series is to present the theoretical formulation and tools necessary for a scientifically exciting and engineering relevant comprehensive analysis of a fluid mechanics problem in nature or industry. Note that this course is on a theoretical method where mostly we discuss the analytical formulations, but We also use certain empirical correlations which have been obtained from the experiment. So the objective of this course lecture series is to present the theoretical formulation, and we will also present certain tools like non-dimensional dimensional analysis, which are necessary for a comprehensive analysis involving both scientifically exciting informations about the flow pattern and engineering informations of the um, fluid dynamic forces which acts on a structure, or the pressure drop which occurs for flow in a pipe. So both considering both scientific information and engineering information, the objective is to present a comprehensive analysis of two types of fluid mechanics problem, the first corresponding to nature and the second corresponding to industry. With this, I come to the end of this lecture 6 on contents and objective of the lecture series. And these are some of the reference books for this lecture. Thank you for